Hey guys, welcome back. Today we're going to be doing another LeetCode 75 study plan series problem. We are now in the linked list category. So the first problem is delete the middle node of a linked list. And it's ranked as a medium problem. Our instructions are you are given the head of the linked list. Delete the middle node and return the head of the modified linked list. The middle node of a linked list of size n is the n over 2 node from the start using zero-based indexing, where x denotes the largest integer less than or equal to x. For n equals 1, 2, 3, 4, and 5, the middle nodes are 0, 1, 1, 2, and 2 respectively. All right, so this is pretty simple. For those of you who aren't familiar with a linked list, this is a pretty good introductory problem to kind of understand what it is. So a linked list is basically think it's comprised of nodes, and then nodes are just like data, right? So in this case, the value is represented as an integer. So in our problem right here, in our example, we have 1, 3, 4, 7, 1, 2, and 6. Those are all each individual nodes. And what the head is the head is the first node in that linked list. And it's called a linked list because each nodes are linked to each other. Just one link, and it points towards the front of that node. So it basically goes to the next node that's in the list, and that's why it's called a linked list. So basically, what we're trying to do here is get the middle of that list, delete it, and then return the new list. So in order to do that, if you haven't worked with linked lists that much, then this is a good problem, right? Because you're going to kind of learn how they operate and how to do whiteboard problems with them. So the first thing that we need to do is figure out how big the list is so we can determine n, because n isn't a given size. We're not given. We can't use an n. We can't just use a method, a built-in method to determine the size of our list like we can with an array. What we need to do to determine the list is have a while loop and then go through each node on the list until the next pointer and the last node is null. That's how we know it's the final node in the list. So we'll set a counter, right, and then we'll determine the size. And then after the size, we can just split that in half, and then we have to delete that node. And then basically how we're going to delete that node is that we're going to link the node from before that middle node to the node that's after the middle node. So we essentially just cut it out, which kind of implicitly deletes or indirectly deletes that node from the list. So enough talking, let's go ahead and implement the solution. The first thing that we want to do is we want to watch out for an edge case, right? Because if you go down to our constraints right here, the node value is greater than or equal to 1, and then the number of nodes in the list goes from 1 to 10 to the 5th power. But that means that the node list can be the size of 1. So if that's the case, then we're just going to return null because there isn't a middle value. It's just the size of 1. So basically, that's a really simple edge case to figure out. We just do head.next equals null, and we're doing head because that's what we're passed in, right? That's the parameter that we're given. So if head.next equals null, then we can just return null. Okay. So now, like I mentioned earlier in the problem, we want to establish a count. So let's set an integer count to 0. All right, and then like I mentioned earlier, we're going to need to pass through the node list twice. Once to figure out the size, and then a second time to delete the middle node from the list. So essentially what we're going to do is create kind of two copies, I guess, of the head where we can start each individual pass. So in order to do that, it's real simple. We get the list node type, and we can call this P1 and set that equal to head, and then we can do P2 and we can set that equal to head as well. All right, so let's go through our first pass. So while P1 is not null, we're going to iterate our count up, and then we're going to set P1 to P1.next. All right. Now, what we want to do is determine our middle index. So int middle equals count divided by 2. All right, and then after we have the count, what we want to do is have a for loop, and what we're going to set up the for loop is to iterate all the way to the node that's just right before the middle. And then what we're going to do is effectively cut out the middle node by linking it to the node that comes after the middle node. In order to do that, let's set up our for loop. So for int I equals 0, and then we go to I is less than middle minus 0, or minus 1, my bad. And then I plus plus. All right, and then this is just one line, so we can just do this right here. P2 equals P2.next. Okay, and then we're out of the for loop. We didn't need to use squiggly brackets for that because it's just one line of code. So we're going to do P2.next equals P2.next.next. So think of P2 as the node that's right before the middle, and then next is referring to the middle node. And we're setting that next node to the node that comes after the middle node. So like I said, we're cutting out the middle node, which is, the purpose of this problem. So now that we've done that, let's go ahead and return our head. And let's run this problem. All right, so yeah, it was accepted, the first 3 test cases. And let's submit. All right, so yes, it passed all of our test cases, so this is a valid solution. And then for the time and space complexity, first off, the time complexity is big O of n, and it's because we're iterating through n times, right? This depending on the size of the linked list, which can be up to size n. We're going to iterate through that with two separate loops, right? They're not nested, so it's not going to be exponential time complexity. It's just big O of n. And then for the space complexity, it's going to be constant, big O of 1, because we're not using any data structures that scale with the size of the input. So we're just using like integers for counting and for determining the middle. So there's no extra space that's needed. It's just going to be constant space. So if you found this video helpful, please go ahead and leave a like and subscribe for more related content. I really hope this video helped you to understand linked lists better. And we will have several more videos in this category, so stay tuned. And yeah, we'll see you in the next video.